The set of irrational numbers. The set of irrational number Q dash, it is that number which can't put in the form A over B, where A or B belongs to Z and B not equal to 0. First, the square roots of the positive numbers which are not a perfect square. This number is irrational number. Example, root 2, root 5, and root 7. All of this number we can't find the square root of them, so it is irrational number. Second, the cube roots of those numbers that are not perfect cubes. For example, cube root of 4 and the cube root of -2, cube root of 11. All of these numbers we can't find the cube root for, so this is irrational number. Third, note Q, which is the rational number, intersect Q dash, which is irrational number, equal 5. Examples. Complete using the symbol Q or Q dash. Number 1, 5 belongs to Q because we can write it as a fraction, which is 5 over 1. Example 2, negative 0.7 belongs to Q because we can write it as a fraction, which is negative 7 over 10. Example 3, cube root of 10 belongs to Q dash because we can't find the cube root of 10. Example 4, pi belongs to Q dash. Example 5, 0 belongs to Q. Number 6, square root of 7 belongs to Q dash because we can't find the square root of it. Number 7, square root of 100 belongs to Q because the square root of 100 equal. Now, finding the approximate value of an irrational number. 1. Find two consecutive integers that root 5 lies between them. Solution. First, you have to find square root of 5 by using a calculator. So, square root of 5 will be 2.23606. So, square root of 5 lies between 2 and 3 because a decimal number lies between 2 and 3. Example 2. Find two consecutive integers that cube root of 10 lies between them. Solution. Since the cube root of 10 equals 3.2075, so the cube root of 10 lies between 3 and 4. Example. Prove that square root of 3 lies between 1.7 and 1.8. Solution. Since this is square root, so we will find each number all power 2. So, square root of 3 all power 2 will be 3, 1.7 power 2, 2.89, and 1.8 power 2 equal 3.2. Now, since 3 bigger than 2.89 and smaller than 3.24, so if we take square root for all of this number, so root 3 bigger than root 2.89 and smaller than square root of 3.24. So square root of 3 bigger than 1.7 and smaller than 1.8. So root 3 lies between 1.7 and 1.8. Example, prove that cube root of 15 lies between 2.4 and 2.5. Solution. Since this is cube root, so we'll find each number all power 3. So first, cube root of 15 all power 3 will be 15. 2.4 all power 3 equals 13.824. And 2.5 all power 3 equal 15.625. So since 15 bigger than 13.824 and smaller than 15.625, so if we take the cube root all of this number, so we can deduce that cube root of 15 bigger than cube root of 13.824 and smaller than cube root of 15.625. So cube root of 15 bigger than 2.4 and smaller than 2.5. So cube root of 15 lies between 2.4 and 5. Example, If x is an integer, find the value of x. Number 1. Square root of 7 bigger than x and smaller than x plus 1. To find the solution for this example, first you have to find root 7 by using calculator. So it will be 2 and decimal number. So x is the integer number, not the decimal number. So x here is 2 and x plus 1 will be 3. So x equal 2. Try to solve number 2 and 3 by yourself by using the calculator to find the square root in number 2, to find the square root of 125, and then we will take the integer that will be x. Find the value of x in each of the following cases and determine whether x belongs to q or x belongs to q dash. Number 1. 4x power 2 equal 9. Solution. X power 2 equal 9 over 4 because we have to write x power 2 inside, so we remove 4 to the other side by divide. So to find the value of x alone, since this x power 2, so we move power 2 to the other side by square root. So x equal positive or negative root 9 over 4, which is positive or negative 3 over 2, and this number belongs to example number 2, x power 3 equal 10. Solution. Since we wanted to write x alone, so we move power 3 to the other side by the cube root. So x equal cube root of 10. So we can't find the cube root of 10. So this number belongs to q dash, which is irrational number. Example 3, 2x power 2 equals 6. Solution. To write x power 2 alone, so we move 2 to the other side by divide, so x power 2 equals 6 over 2. So x power 2 equal 3. To find the x, we will take the square root of 3, and this number belongs to irrational number. Example 4, x minus 2 all power 3 equal 1. Solution. X minus 2 equal cube root of 1 because we remove power 3 from side and move to the other side as a cube root. So x minus 2 equal cube root of 1, which is 1. So x equal 1 plus 2, move minus 2 to the other side by the opposite sign, which is plus 2. So x equals 3 and 3 q. The set of real numbers. We took in the previous years that we have sets of numbers like natural numbers, integers, rational number, and irrational number. All of these numbers will be on real numbers. So real numbers contain all of these sets. Some notes on real numbers. Q, the rational number, union Q dash, which is irrational number, equal LR. If we take from real numbers q, so we will get q dash. So r difference q equal q dash. And r difference q dash will be q. So the real numbers equal the real positive numbers union 0 union real negative numbers, which is r plus union 0 union r minus. And then R star means the positive and the positive real number and the negative real number. So it will be R plus union R minus without a 0. And Z belongs to the set of rational number. Example, arrange the following numbers ascendingly. Square root of 62, 8, negative square root of 50, and square root of 70. Solution. First, we have to write all of this example as a square root. So, square root of 62, and the 8 is a square root of 64. So, we will write it as a square root of 64, and negative square root of 50 and the square root of 70. Now, make a range ascendingly from smallest to greatest. So, it will be negative square root of 50 and root 62, root 64 and root 70. So the final result will be negative root 50 and the square root of 62 and the 8 and the square root